Hello and welcome to the C# 101 and Introduction class. This is the third week, so we're at the halfway point after tonight, and it is March the 15th, 2012. We're currently looking at Nelson's screen, so we're ready to get things going. Tonight's first test with BuzzNet, the web-based BuzzNet, so this should be a lot of fun. I'm sure we'll see an explosion or two before it's all over with. But yeah, so tonight really it can be summed up into four things that we're going to be looking at. We're going to be taking a look at lists. We're going to look at for loops. We're going to look at for each loops. And we're going to be looking at switches. So an introduction to all of these things. Should be a lot of fun. Please get involved. If you have questions, if you are confused about something, do not be shy to ask. You have the questions panel. Please use it from the webinar to throw your questions in. If you put them over in the chat, every now and then we do see those questions and we'll answer them. But we're not actively monitoring the chat for questions. But we are actively monitoring the questions panel in the webinar system for your questions. So if we can all use that, if we're trying to... look at Phantom Walker. He's now playing the 101 class.
Wow.
I meant to ask that too because he does a lot of non-Steam stuff in there, and I was curious on how he got it to do that. But anyways, you gonna? Yeah, thank you very much. So yeah, we got a few things to look at. Put questions over the questions panel. Let's get started, Nelson. So we're gonna start out with lists.
Okay. So lists. I'm going to go ahead and get Visual Studio up and running, which it was. And I'm going to fire up a console application. Eventually.
Oh, just get a faster computer.
Well, at least it doesn't freeze my host now that I have it on an external drive.
That's true.
Okay, so basically we're going to talk about lists, and lists are their type. It's a type provided to you by the .NET framework, and they're really awesome. They're basically used for storing, well, lists of data. Very similar to arrays, but there's some very key differences between lists and arrays that we're going to be going over.
So let's start out like we did on Monday with an example of an array again, and then we'll end up converting from that over into the example of a list so they can see the differences right up on their screen.
Yeah, if you were to write a program that took in an arbitrary amount of product names and stored it into an array, it would look something like this. And most of you are going to be familiar with most of you are going to be familiar with this sort of stuff. Then we'll go ahead and enter a while loop. So while index is smaller than number of items, go ahead and say console.write, enter product name, then just make that one based. Present it a little bit nicer. Then we can do product names at index equals console read line.
And like Darth, yeah, there you go. Darth Greg was all over it, making sure you put your incrementer in there.
No,
It's all good, man.
It's not a for loop.
Yes, elevating. He is getting better. I'm very proud of Nelson.
I just never write while loops.
I know. We all know, man. We know.
So if I wanted to enter three products names, I can go stuff and things, and I get back stuff and things. So everybody should be comfortable with this sort of code by now. We've written it quite a few times up until this point. If anybody has any questions, I suppose I could answer them. But
You suppose you could? It's awfully kind of you, Nelson. I suppose you could too.
Ah, but will he?
Ah, but that is the question of the evening.
Alrighty, so I suppose, yeah, it looks like everybody is good. Now, this code has a few problems that are already quite apparent that can be solved by lists. The biggest issue right here is we have to predefine how many things that we want to store in the array when we instantiate the array. Because remember, when you instantiate an array, you give it a length, but there's no way to change that length further down the line. The only way to even come close to mimicking that behavior would be to instantiate an entirely new array with a larger number, copy all the values from the old array into the new array, and then dereference the old array. And that would be just very obnoxious to have to do, and just overall, because of the fact that arrays are constrained to how many items that you start with, doesn't make them very useful for a lot of scenarios. Particularly in this case, we are basically given a really shoddy user experience to the user because they might have a variety of different products they want to enter but not know an exact count. So we want to give the user a way to enter products as many as they want until they tell the program that they no longer need to enter products anymore. So now we're going to talk about lists. And do you want people to write this down? And then...
No, they don't. They don't have to do that one. I definitely want them to follow along with the updated example.
Okay. Okay, so lists. I'm going to go ahead and type out some code real quickly. Eventually.
So at this point, starting with what you're typing, why don't you get everyone to click the participate button and then send off a reset pulse. Whoa, that's just psychedelic.
I know. All the jumping colors.
So everybody go ahead and click on not ready.
Actually, I just hit the not ready button.
There we go. All right, thanks, guys. So everybody just leave it on not ready at the moment. All right, but follow along with Nelson. Let's go.
Okay, so, well, I was actually going to sit here and explain this, at least this line of code.
Yeah, go ahead and explain it.
Okay, so what we see right here kind of looks like a normal variable definition with an initializer that uses a syntax we haven't really covered yet. But there is also something interesting about the type here. Now, I want to point out that list is a type, and list is a type that's provided under the system collections generic namespace. So if you do not have this using declaration at the top of your file, you'll have to fully qualify it as system.collections.generic.list, or alternatively at the using statement. So the list is a type, and it's a very interesting type. We're not going to necessarily cover the means in which it does what it does at a language level, but there's some very important things that people need to understand about lists. First of all, this is not valid whatsoever. Just a list. A list as a type is not valid. This is not valid either. This right here, what you're seeing right here, is technically the type. This is the type of list. But what's interesting about this type is you cannot actually make a variable out of this type. That is impossible. You have to specify what's called a type argument into it. And if that sounds confusing, think about a type argument just as another type, another static reference to a type inside of code. We can place int as our generic argument. We can place bool as our generic argument. We can place decimal as our generic argument, and so on and so on. If you want to go really crazy, we could do list of int, but you know, that's just going crazy. The point here is that this list type must be supplied a generic argument or a type argument inside of these angle brackets in order for it to be considered valid. Now, when you're doing so, this actually does modify the type of what we're looking at. So the way you pronounce this type is list of int or list of integer. This list of Boolean, however, is not the same type. You would not be able to assign a list of Booleans to a list of ints, because that would make as much sense as assigning a array of Booleans to an array of ints, or that would make just as much sense as saying assigning a Boolean to an integer, which is impossible. So I just want to at least talk about the pronunciation. This is list of int. The fact that what you provide as a type parameter, you may only specify one in the case of list. There's no way to do that, for example. And that the generic argument you specify will change the actual type of what you're working with, meaning that a list of int is not in any way compatible with the list of bool. So yes, so that's at least just a basic rundown about the syntax, and just get used to typing out syntax like this. So it's the list followed by an open angle bracket, followed by a type, followed by a close angle bracket. And I do want to point something out as well. These whatever you provide as a type must be an actual static reference to a type within the code. It could not, for example, be this. Because this is a value, not a type, there's no way to satisfy a type parameter with that argument. So that's the first part of this line of code right here. We start off specifying that we want a list, but more specifically that we want a list of string, which is the only valid way to go with this. You must provide a type when you ask for a list. Now, the rest of this line continues like a normal variable declaration, where we have our identifier giving our variable a name. Then we have this right here. And the only place the complete beginners here have seen this syntax is in the case of arrays. And you might have noticed that I've used the word instantiate. New is an operator within the C# programming language, and what its responsibility is to instantiate an object at runtime. Now, actually talking about how types are instantiated and all that stuff is going to be something we'll be covering in week 5, I believe. Or sorry, week 6.
Yes.
But just in this case, you remember that list is not a basic type. List has no literal syntax in the C# language, such as like int I equals 10. So in this case, we simply assign the integer or the variable I to the constant of 10, because the C# compiler understands this constant and gives it a type. In this case, we have to instantiate this variable to a new list of string, and there's no other way to do this. So this is, if it's not entirely clear why you would need to do something like this, we'll be getting into that. But just in the case of lists, you have to provide, or you have to instantiate the object and assign it to your variable. Okay, so questions at least up until now. I noticed, is there a way to have a list of user-defined types, such as a C++ record? Yes, any valid type, you can provide any valid type into the type parameter, which will include any user-defined types. But obviously, we haven't defined any types yet, so there's not much I can show in that case. Yeah, Segfault brings up, if you are familiar with the C++ vector class, the list class in C# behaves exactly the same, including how it works internally. Does the list have a min or max limit? Well, I'll get into that once we start filling up stuff with the list, but I mean, as far as the min and max limit, that's going to be limited by a few different factors. You're going to be limited by how much memory you have, and you're going to be limited by the maximum value an integer can represent, simply because that's, well, how you access items through a list. Okay, actually, that's a good point. Adam asked, why are there parentheses at the end of this instantiation? I want to point out that whenever you see parentheses in C#, a good bet is to think of a method invocation. So in the case of line 14, we have a method invocation right here. We have console.write. On 15, we have int.parse. All of these are method invocations or methods that we invoke using parentheses. And we've been doing this quite a bit throughout the last few weeks. In this case, this is actually invoking a method. The method it's invoking is something called a constructor, which is going to be a method that's specific to the list type that's responsible for doing all the housekeeping required to make list work. List is basically an abstraction over a lot of operations and behavior and code that we don't want to write ourselves, so list does it for us. And list has to start or has to be initialized into some sort of value, or it needs to do its own housekeeping in order to work properly, so we need to invoke its constructor. And that's what's happening here on part of the syntax. Whenever we instantiate an object, we have to initialize it, invoke its constructor, with the case, of course, of arrays, which we don't. Arrays are kind of strange types of instantiations. Okay, so now that I've talked about list just in a very general sense, the different components of how you initialize it, so there we can link us to read up on lists. MSDN is going to be your best bet to read up on anything in the .NET framework. If you were to search the words system.collections.generic.list in Google, the first result should be an MSDN link. But yeah. So now that we've talked about, well, how to make a list, how to instantiate a list, how to represent a list as a variable, we've talked about how we are required to pass in a type as an argument into the type itself. Now let's talk about what lists actually do. And lists are basically going to be very similar to arrays, with one difference. And that difference is that it's going to allow us to add as many items as we want at any point, as well as remove any items that we want at any point. So it gives us a lot of flexibility over our normal arrays and allows us to express things in our code that we previously couldn't. Now, the method we're going to be working with most is the add method. And so you see that I have product name list dot add. So I'm actually invoking a method on an object or on a variable that we've instantiated. And in this case, I'm invoking the add method. And the add method is very interesting because it allows us to, well, pass in a single string, of course, in this case. And you'll see that right here with this string item. Now, here's why it's important for, well, and I'll also follow this up because we can also do this. This isn't the example that I want people to write out just yet. I'm going to be refactoring this in a moment. But okay, so we can also do basic indexing operations. And you'll notice, in addition to the add method taking in a string and the index operation returning a string, and the setter for the index operation allowing us to set it to a string, but not an integer. For example, this would be invalid code. And the reason why all of these methods deal with strings is because we provided string as the generic argument into this class. So if we were instead going to provide an integer as that generic argument, we could we would be able to do stuff.add, and then notice the signature here. The signature requires us to pass in an integer rather than any other type. So we can pass in an integer, but we couldn't, for example, pass in a string. So that's where the generic type or generic argument comes into play, is how or what kind of data that a list can store. Just like as an array, you have to specify the type. With using a list, you have to specify the type as well. So let me go ahead and I'm going to rework this code really quickly. Or I don't necessarily have to delete it. I can stick it in somewhere. Just in case we need that. Okay, so then I'm going to rework this code a little bit. So instead of a string array of product names, we're going to have a list of string product names, and then we have to instantiate it to a list of string. Then I'm simply going to say while true, or no, I can't do that just yet. I can say Boolean exit equals false. And I can say while not exit, and then I can say enter product name or nothing to stop. And then I could say product or string product name equals console.readLine. If product name is blank, then exit's true. Otherwise, product name is not add product name. Followed by int index equals 0. Index is smaller than product names.count, which we'll talk about pretty shortly here. And then product blah is product names.blah. I'll go ahead and run this program, and then I'll ask everybody to go ahead and copy it down. So you see I was able to actually provide as many products as I wanted, and then I would get a nice formatted list down here of all the products that I entered after I told the program that I wanted to stop by hitting the enter keyword. So I'm going to go ahead and go full screen, then reset everybody's ready check, and go ahead and copy that down. You have to specify an index, or it will automatically assign it to the next index with add. It'll automatically assign it to the next index. It'll continuously add indefinitely. Oh, yeah, good point. I'm going to do something real fast. Nobody pay attention.
That just helps out a lot when you put dot at the end.
Yeah, I don't want to scare anyone with
Exactly.
All right, so go ahead and when you're done copying this code down, hit ready. If you need a little bit more time, hit 1 minute. And there, the seizure-inducing user list is back.
Sweet. Very nice seeing a lot of you guys using the 1 more minute. Very, very nice. How many exceptions have we had so far, Nelson?
Just one.
Wow. Do you see what caused it?
No idea.
Okay.
Somebody changed their participation and it blew up.
Gotcha.
That's all I know.
I would say, though, that I have not managed to get it to work for longer than it shows the little spooling thing as the page loads, and then it just stops updating.
Huh.
That's in Firefox something or other. Actually, I'm not sure what version I'm running. It may need updating. Where does it tell me?
It really shouldn't need up this. The platform that I'm using for the long polling should work on older browsers. I'm wondering if it's just your connection.
How does it rely on a... never mind.
Well, what it does is actually opens up an HTTP connection to the server, and the server leaves it open and continuously streams data back into the client. So it's all done over port 80. But
oh man, I'm only on version 5 of Firefox.
Oh.
Haven't they spooled out like bazillions of updates in the last few months?
Yeah, I'm just updating to 11 right now.
I just hit apply update.
All right, you should be on 11.
All right, just a few more of you guys. Remember to set your ready once you're ready.
Oh, I bet I have to be logged on as a admin to do that.
Somebody asked, so you never use an array since lists are better? Yeah, I I don't use lists very often, or
You don't use
arrays very
lists?
often. I don't use arrays very often. I don't even. It gets complicated. I'll use lists for a lot of stuff, but often I just use enumerables. But we haven't gone through that yet. But yeah, generally speaking, if you have an array, or if you find yourself in a position where you need to use an array, just use a list instead. The arrays are much simpler and much easier to reason about, and they're definitely important to know because, well, it's one of the main features of the language. But the whole point of introducing arrays early on was just to get those concepts down, and then moving on to a more complex but more powerful framework or collection type. Looks like everybody's just about ready. Almost everybody.
Yeah, so again, once you're... All right, we've got a couple of you left. If you're still typing this out, please make sure in BuzzNet to click on the 1 more minute. Otherwise, we will assume you've gone AFK. All right, good. Thank you.
Or disconnected.
Or disconnected. Well, we did have 1 switch over, 2 switch over. Beautiful. All right, not a problem.
Do you ever just lose a variable?
Where did I put that thing? Darn it.
Well, they've been in so many different places. They keep moving around, and I can't keep track of where they are now.
How is the performance issues between an array and a list? That's a good question. Internally, lists do use arrays, actually. In fact, when the list starts off with having an internal array of X many items, I don't know what the default is. Then once you add items to the list to the point where it can no longer fit the items you're adding to its internal array, it'll go ahead and instantiate a new array that's twice as big, and so on and so on. The performance differences you really shouldn't worry about. I suppose if you want to get nitpicky, then there are some issues. I mean, there is, a virtual function call over a static call, and just stuff like that. But that's very esoteric, and really, as far as when you're actually designing your program, there's no reason to use an array over a list for performance reasons unless you know exactly what you're doing. There are cases where, very, very rare, I want to stress how incredibly rare these are, where using arrays could lead to performance benefits, but you shouldn't worry about those particular cases right now.
Yeah, they're very specific. All right, we've got everybody ready. That's awesome.
So yes, we have code. It's a question. If you use index++ in the console.writeline, will automatically add one to the index, then spit it out. We haven't really talked about the
pre and post.
We haven't talked about the difference between pre and post. However, that will work. I'll generally avoid doing that, however, because I like my increment operations to be very clear to where they are. I think that this code is a lot less clear and might result in somebody else incrementing the index variable again just because they don't immediately see where it's being incremented in your loop. Alrighty, so we have a program. Pretty straightforward program. We start off with defining a variable up here, and the type of the variable we're giving it is the list of string. So say that with me: list of string.
List of strings.
List of string.
List of strings.
List of string. And then we
string.
Yes. Yes, and that's very important because again, I just want to stress that people might get confused as to why the angle brackets are there, what could go in there, what happens if you don't put an item there, what happens if you put multiple items there. Just remember the angle brackets define type arguments, and list requires a single type argument, and that type argument is going to define what kind of objects that list can store. So we start with declaring this variable and as a list of string and instantiating it as a list of string. Why we need to do this we're not getting into yet, but just that's the word, instantiating, and that's what we're doing here. Then we define a Boolean called exit instead of false. We're going to be using this Boolean to exit out of the loop based off something a little bit more complex than a simple index incrementing operation. So then we start the loop and say while not exit. So while exit is false, go ahead and prompt the user to enter a product name, retrieve the product name from the console, then do a basic conditional here where we're asking, did the user simply just hit enter? And if they hit enter, product name becomes an empty string represented by this right here. If they did, go ahead and exit the loop. If they didn't, go ahead and add it to the product names list at the end of it. So this will append on an additional item to the list, something we previously could not do with arrays. So we'll continue to loop and loop and loop until the only one exit condition is going to be when the user simply hits enter. We get an empty string. We set exit to true. We jump back up all the way to the loop. We ask the loop, should we exit? The loop says yes, because not exit. If exit were to be true, that would return false, and then the while would terminate. Then we continue execution here on line 27. Line 27, we declare and initialize an index variable to 0. We begin a while loop where we say index is smaller than product names.count. Now, if you'll remember, arrays have a .length property, but lists will have a .count property, and they're the exact same thing. The length of an array is going to be how many items are in it, and the count of a list is going to be how many items are in it. There is no length property here. So count is the only way to acquire that information. So while we're looping over every single item in our product names list, we're going to go ahead and write it out. So again, fairly straightforward, console.writeLine, start with the string literal product, add a index plus 1 to it, because our index is going to be by its very nature 0-based, but when presenting it to the user, we want to convert that over to 1-based, followed by a colon, and then followed by product names at index. So that's going to go ahead and behave the exact same way that an array would behave, in that that's going to ask for a 0-based integer that represents how many items forward it has to go to select the item you want, and then it'll return the string at that specified index. Finally, we increment our index variable, and we continue looping until we run out of product names to display, and then execution resumes on line 34, and we hit console.read key. Hello?
What is it, Gavin? Yeah.
Watson just said finally, and then it will cut off.
Yeah, that's just going to chalk that up to connection.
Yeah. Well, finally we hit console.read key, and then everything is pretty awesome. So, questions?
There's one there from Adam.
Actually, someone asked, I just got here, where is BuzzNet Web? It's going to be
BuzzNet.3dbuzz.
Yep. And if you get here, that's where you're supposed to go. So buzznet.3dbuzz.com. Okay. If you wanted to have a specific amount of items in the list, would it be better to use an array, or can you tell the list to be an exact count only? It would still not be better to use an array. It would be better to enforce that through your user interface and not through the restrictions of the data structure you're using. There's no way to specify a max amount of items to a list. It will always be able to add as many as it wants. But again, if you wanted to limit how many items a user could enter, you could simply write logic in the UI that prevents them from entering that many items. And then if you wanted to validate how many items the user entered, you can always validate against the .count property. I noticed that a lot of your while loops are while not something. Is the style or best practice? Style, I would say. I like the exit. I mean, of course, once we get into different looping constructs, even in this video, there's a lot better ways to handle this sort of logic than using a variable like that. But I generally just prefer the Boolean exit. I think it makes more sense to me. Does the empty string get added to the list? If so, should you remove it if it was a real thing? The empty string does not get added to the list. And the reason it doesn't is here on line 17, we have an if statement that says if product name is equivalent to empty string. If it is, if this statement is true, then we immediately go into line 19. However, after line 19, we skip everything else because the only other bit of code is attached to an else block. And this else block will only execute when the if statement is false. So if product name is empty string, then we'll exit and nothing else. If product name is not empty string, then we'll add it to the product names list and nothing else. But what are the benefits of using list versus an array? Well, in this particular program, we're capable of adding as many items as we wish into this product names list. Remember how before, I do have this code up here in Notepad, with the array syntax, we were only able to predefine the amount of items we wanted in the array, and then we were constrained to only being able to add that many items to it. With the list, instead, we can invoke the add method and add as many items as we could possibly ever want to that object. All right, so are there any more questions about this code here? We're just demonstrating how to instantiate a list, how to add items to the list, and finally, how to retrieve items back from the list. Those are the three new things here. So if everybody's good, we can talk about removing items.
Sounds awesome.
So if we wanted to write a really, if we wanted to continue this fairly worthless program and make it even more worthless, we can give the user the ability to delete items out of the product inventory until there aren't any items left in it. So to represent that code, I'm going to go ahead and delete our index variable because we no longer need it. Instead, what I'm going to do is I'm going to say while product names.count is greater than 0. And then I'm going to bring back my index and enter in a different loop while index is smaller than product names.count. And then I'm simply going to say console.write select product index to delete. Then we'll say product index to delete equals int.parse console read line. Okay, so far everything's straightforward. We're entering a loop that will continue looping until product names is empty, until that list contains 0 elements. And at the beginning of every iteration of the loop, we're going to go ahead and print out all of the products, just like we were doing before. And then we're going to prompt the user to select a product index to delete, and we're going to store the result of that in an integer product index to delete. So now how do we delete an item out of a list? Well, there's 2 ways. We have remove and remove at. And these are the main 2 ways that you're going to remove items from a list. not going to be talking about a remove just yet. There's a bit of funkiness with that method that we'll talk about. We're going to be using the RemoveAt method. And the RemoveAt method is going to go ahead and remove an item at the specified index. Okay, so we say product names.remove at product index to delete -1. The reason we say this -1 here is because remember the user is going to be seeing a one index variable or one indexed array or collection of products, and when we want to go ahead and convert that back into code, we have to go ahead and subtract 1 so that their choice lines up with the actual indices inside of our list. So everybody go ahead and copy down that. Did I answer your question, Alan, earlier? Just wondering if I made sense. Alrighty. Goodbye, Segfault.
Good night.
No stamina, you for today. Actually, to be fair, he's had toothache all day.
Oi!
Shut up. I don't even know what that is.
It's northern for be quiet, please.
Oh. It's a very odd language.
Yes.
Am I intentionally not bringing up clear? I just wanted to point out RemoveAt right now. There's another method that allows us to do it, but it wouldn't be very interesting, at least from a user experience point of view. I mean, why make the computer do everything for you?
I like the way he goes straight for the blow it up button.
Yeah.
Okay, just remember to click the ready once you're done. There we go. Really impressed, Nelson. This is the most stable of a first release I've seen yet.
Yeah, it's the first time you've used Signal R2.
I know, that's what I'm saying.
Encouraging. The only reason I even considered using it because it's apparently backed by Microsoft, but it's still in beta.
Right. Seems to be working pretty well, though. All right, so just a couple people left. For those of you that are still out there working on it, go ahead and hit the 1 more minute button for me. How you doing, Meta? Good? Did you click the done? Ready? Agreed? Thank you. Okay, everybody's now good to go. So let's continue.
All right, so if I were to go ahead and run this program, I can enter a bunch of awesome, interesting product names. And then I can continue, I can go and delete them. And then I can cause an exception as well. That wasn't part of the demo.
Want to see a magic trick?
Yeah. Okay, so the point here, though, is that we are seeing basic input and output using lists. And, well, we can type in 1, and we delete the item at the first index. We type in 2, delete the item at the second index. 1 again, or 2 again, and then 1 again, and finally we have no items left. So that really kind of demonstrates the nature of lists, where we can add and remove items at will, compared to arrays, where, I mean, you can set items, but you can't add or remove items. So that's a very interesting feature that lists gives us that we simply do not have with arrays, and is a very good reason to favor lists over arrays.
Well, Nelson was requesting a break, guys. So, Nelson, if you need one, we can go ahead and pause right here.
Yeah, I'll go ahead and get the code up on as much as I can, at least.
Okay, so guys, we'll go ahead and take a break, 10 minutes, do what you need to, and then meet back. And so I'll see you guys in 10 minutes. So I'm actually going to pause recording, and we're resuming. Sweet.
Awesome. So, okay, so we've already talked about a bunch of different things that we can do with lists. We've talked about instantiating lists. We've talked about adding things to lists. We've gone over one way to remove items from a list, but there are 2 more ways to remove items from a list that I want to talk about real quickly here. I'm going to go ahead and create a new list up here. Let's just say a list of integers, and call these prices or something. And I'm going to say prices.add, and I'm just going to add a bunch of arbitrary prices to this list. Okay, so we've talked about the RemoveAt method. Now, the RemoveAt method, again, lets us remove an item from the specified index. Remember, zero-based. We also have the remove method. Now, the remove method is interesting because it actually does some non-obvious behavior. The remove method will remove an item from the list by value, meaning if I were to type in 31, at this point, prices would not contain the item that I added in here on line 14. Now, let's say I had 2 31s. In this case, the behavior of this method is going to go ahead and remove the first occurrence of the value 31 and then return immediately afterwards. However, it does give us a nice little hint in the signature right here, because it has this bool return type. And the bool return type will specify whether or not it was successful in finding an element. So if we wanted to, for example, actually, I wonder if this would be good exercise.
Yeah.
To get people to remove every instance of 31 from the list.
Sure.
What's the best way to go about doing that? The exercise, I mean, not the code.
Yeah, I know. Reset everyone. Tell them what you want. And as soon as they have it, click on they're ready. And if they just get completely confused and cannot do it after a couple of minutes, just click the 1 more minute. But that means we can put a I'm confused state in there, which would be pretty funny.
Yeah. Okay, so the goal is write code that would remove 31, every single instance of 31 from this list. Now remember that remove by default does not remove every item. It simply removes the first item that is matched by the value. So, yeah.
Stuff and things.
Stuff and things. Words and code. I actually had to write a comment today.
Did you?
Yeah. Remember the really bizarre signal R behavior?
Mm-hmm.
I had to comment that because after writing the code, I was like, I know exactly what this code's doing, but I'm not going to remember why I did that. Let's see, it was that one. No, I've always made that exception.
I know that
when there's code that you're dealing with that is just does something stupid, then you have to make it apparent that you're not stupid yourself.
Now remember, Java, the idea is to not post answers or thoughts over there, but to see if you can get it, and then if it works after you verify it, just click the I'm ready.
And be sure to remember what remove returns. It returns a Boolean. Silence. There's too much silence.
Sing us a song, Nelson. Entertain us with some pony stuff.
No.
Yes.
Oh, did you see what I posted to you on Skype and on Facebook today, Jason?
The smile.
Yeah. Fat Gav, you would actually appreciate this. It happened to be a pony song, but they actually played it using a bunch of old floppy disk drives that they had configured to make particular noises with the motors at specific times.
Oh, nice.
It was very well done. Okay, so just another minute. Again, remember, if you get it, go ahead and click on the ready. Nelson, they really want you to sing that.
I can't. I don't sing.
You can too. I heard you singing that pony stuff the other day.
I've never sung a pony song.
You did. Well, you were humming it.
I was probably humming it. I sometimes whistle to them, but I don't sing them. Saganatsu pointed out something funny that I think I'm going to bring up in a moment. Do you see that, Jason?
What's that?
In the chat.
Okay, this is probably good, but we'll go ahead and continue.
Okay, so the most basic implementation that I was kind of thinking of, some people did do something a lot more terse than this, but I'm going to show the very basic implementation.
Go ahead and fix your if statement. Thank you.
Okay, so this is the simplest way to do this, to perform this sort of operation, and it wasn't necessarily about the about this particular scenario itself as much as it was an exercise in logic. But as you see, what I have here is a Boolean, an exit Boolean again, while not exit.
Yeah, I wouldn't say that's the simplest approach, by the way, but continue.
Oh, see, there's a difference between simple and straightforward.
Continue. Continue.
What you mean is there's a difference between simple and concise.
Yeah.
Yeah. Continue.
So this is simply saying, this is the logic all spelled out, where we have while not exit, if not prices.remove31, then exit equals true. So we'll continue this loop again and again and again until remove returns false. And when removed returns false, that means there's no longer an item called of value 31 in our list, and we get an exit condition. Now, another way, that a more concise way that people were posting was something like this: while prices dot remove 31 terminator. Again, a lot more concise, but again, not necessarily as simple. It doesn't spell out the logic as well as the first example. But this is a case of a very concise way to do it, the same amount of logic, where prices.remove returns a Boolean. Therefore, we can place this value inside of a while statement and get the behavior that we're looking for. Of course, if you ever wanted to do this in production code, there is a RemoveAll method that does take in a predicate, but we're not going to be talking about those. So this is going to be the simplest way to, or the top way is going to be the most concise way to go ahead and remove every item with the value of 31 out of a list. So is everybody kind of clear about why this code works, or at least the logic behind this code? Remember, this code and this code are functionally equivalent. This one is just considerably shorter. So if everybody's good, I guess we can talk about the third way to remove items from a list. And the third way to remove an item from a list is going to be prices.clear. The clear method will remove every single item out of the list indiscriminately. So the methods I wanted to talk about on list today were add, the indexer, remove at, remove, and clear. I guess before I move on, is there any questions about any of those things? Because we're about to go forward, if there is not.
Putting lists to the side for a moment.
Well, I do want to point out that console right line thing first.
Okay.
Because that might be legitimately confusing for some people, but it has a very defined behavior as to why it does that. Alrighty. What's the difference between clear and remove all? Remove all is a little bit more of an advanced method that requires that we pass in a predicate.
Meaning, the simple, as you can see right there in bold, match. So we can basically say remove all, that's 31, for instance.
Right.
Where clear is remove all.
But we're not talking about that syntax. So that's definitely going to be a more complicated method that, we don't want to deal with that right now. Okay, so somebody did bring up an interesting thing about lists, and I'm going to go ahead and start a new solution and leave this in the background. I guess we need to go back to it. Okay, so somebody pointed out that if you do list event prices, new list event, let's just add some arbitrary item to it. Let's do console.writeLine prices. So what's everybody's guess as far as the output of this program? You're not allowed to
Jesse.
to answer, Saganatsu. I love how it turned the odd www into a link.
Yeah, I know.
Alrighty, so I don't see a whole lot of guesses, so I'm just going to go ahead and, there's one, writes out the first index. Somebody said something like name of type, stuff like that. So I'm going to go ahead and run it. And look at that. Now, what is this? List is an object. And if you look at all of the overloads of the writeLine method, there is one that does take in an object, but there's nothing that takes in something more specific. There's nothing that takes in a list directly. So it's going to fall under this little object overload, which is going to be the exact same as doing prices.toString. And remember from the first video, or the first video, maybe the second, we talked about toString, where toString, every single object in .NET has them, but in certain cases, they don't make much sense to do anything useful. So the default behavior of toString is going to be what you see right here. And this is the type of our variable. And so remember how I already said list is in system.collections.generic? So you see that right here, system.collections.generic. This is the namespace of the type. This is the type itself, and this is our type parameter. So you see how everything kind of comes together. We have our type parameter, which is int, like you saw right here, or system.int32 specifically. We have the type itself, which is list, and then we have the namespace. And so whenever you see something like this, don't be terrified. It just means you accidentally outputted an object instead of what you meant to. But I just wanted to point that out really quickly because I could see some people trying to do a write line of a list and expecting maybe a comment delineated list or something like that. But you won't actually get that from writing that code. What's the part between list and system.int32? This tilde1 is how many generic arguments went into this type. Now remember that list only accepts one. You can only pass in one generic type or one type argument into the type itself. But this one here just simply indicates that this is the list type that accepts one generic argument, and this is the generic argument we passed in. If list were to accept two type parameters, there would be a tilde and a 2, followed by one type here, separated by a comma, and then another type right here. Okay, so now moving on, I guess. What's next?
Well, at this point, we need to take a look at, and again, just like I said the other day, whichever way you want to do it, but we could go ahead and start with regular for loops. I think we went ahead and followed the outline with regular for loops. So we got for loops, for each loops, and switches.
Alrighty. And then at some point break and continue, I think, because we did that in the last class.
We did throw that in as extra, so absolutely.
Okay, so we are going to be working with for loops now. Okay, so we have these awesome different constructs that we have already, learned about C#. We have the if construct, the basic if statement. We have the while loop if we want to do looping. But there's another one that's a little bit more powerful. It's another loop construct, and it's called for. And the for loop begins with the keyword for, so that is a C# keyword, followed by an open parenthesis. Exact same as whiles and if statements. But something very interesting goes inside of these parentheses, which I'll talk about in a second. Finally, if you were to fill those with something valid, you would enter a block. So the basic sort of syntax that we've seen before, keyword, parentheses, block. It's a very common pattern in the C# language, or in any C-based language. Now, what goes in this parentheses is interesting. There's actually three things that we can put in here, separated by semicolons. The first part of a for loop is going to be the initializer. The second part of the for loop is going to be the condition. And the third part of the for loop is going to be an action. Okay, so to break down each individual part, first part declares 0 to many variables. In this case, we declare the most common use case for a for loop is to declare a single variable and assign it to a value. If we were not to assign this to a value, we would actually get a compilation error, as you see right here, use of unassigned local variable I. So if you declare a variable inside of the first part of a for loop, be sure to initialize it to something. The next part is the condition. This condition is perfectly equivalent to what would normally go inside the while loops parenthesis. Remember, So hopefully people can start seeing the parallel of what's going on here. We have the variable declaration, 0 to many variables. Just like if we were to loop from 0 to 9 inside of a while loop, we would start with a variable declaration declaring our iterator variable, followed by the condition. Again, this is the part that you're already used to with while loops. If this condition becomes false, for any reason, the for loop will break and continue execution on the line below it. Same thing with right here. That is the condition of this while loop. Then finally, we have an action to take at the end of every iteration. And in this case, this is the increment operation that you would normally see on its own line inside of a while loop. So what's going on here is, again, we initialize a variable to 0. This only happens once. This happens once. Next, we check to see, is I smaller than 10? This happens every iteration of the loop. Then we go enter the block of the loop and perform all the actions specified here. Remember, we can also access this I variable because it is in scope. In this case, it's going to be 0. When we reach the end of the for loop block, we come all the way back up and we execute this action, so I++, which will result in I being 1. Immediately after the action, we go back and check the condition. Is 1 smaller than 10? No, it's not. Sorry, yes, it is. So that means that we continue execution of the loop. We enter the block again. We compute the block, hit the last closing curly, and then we loop back up into the action. Then we hit the condition, and then if it's true, block, action, condition, block, action, condition, block, action, condition, until the condition becomes false. So until I becomes 10, this loop will continue to execute. So if I were to run this program right now, we'll see 0 through 10 or 0 through 9, which is the result of our while loop. And I guess I can go ahead and put in a doohickey thing here.
Doohickey?
Yep, there's my doohickey. So you see our while loop iterating from 0 to 9, and now you see our for loop iterating from 0 to 9. Same exact logic represented with a more powerful language construct. So I don't know, I guess I can go ahead and I'm going to keep this part up actually just for demonstration purposes, but everybody go ahead and write this out, and I'm going to reset you guys. And go ahead and hit ready when you have your for loop written out. So those colors would look so much nicer if it was in order.
I don't even have a problem with, I don't know, you could just put the whole thing in alphabetical order. I mean, just looking over at it, your eyes quickly, well, I guess if we have more people than would show on the thing, yeah.
It's kind of supposed to. According to the logic I wrote, not according to the logic it actually ran, which sometimes is a different thing, it was supposed to sort by participating, then ready status, then by name.
Gotcha.
But JavaScript being what it is, it decided to be.
Well, yeah, okay. Still, I'm quite impressed with how smooth of a test this has been. I mean, we're using it in a real class, and it's holding up well.
No more exceptions, just that one.
Awesome.
Okay, so is the initialize part required? No. None of the individual parts of a for loop are required, and I'll get into that in a second. What I have up on the screen, though, is the most common use of a for loop. The use that you will see most often. I'm going to use that next time. It's not using the logic I wrote. See, with JavaScript, it is like that. It feels like you're just.
It's okay, Nelson.
It's like, I see you wrote this code, but, you know, I'm bored today, so I'm going to mess with you. All right, so people are becoming ready.
So yeah, so don't forget, if you're still typing it out, hit 1 more minute. All right, so we might have a few AFKers. So
Or yeah, or a few people who quit or something, I don't know.
Yeah, that's true too. Yeah, so let's go ahead and continue.
Okay, so to reiterate, no pun intended, the loop construct, we start off with our initializer, followed by our condition, followed by the action at the end. So yes, does anybody have any questions? There was a question that came in that asked, is the initializer part required? The answer to that question is no, but I want to talk about that after I make sure that everybody's at least comfortable with the basic utilization of a for loop. But yeah, it's going to be this, basically. For initializer, condition, action. Yep, it is much easier to use than while loop. Okay, so valid forms of for loops. Any part of a for loop can be omitted. In addition, we can omit, well, every part of a for loop if we wanted to. But if, for example, I had a variable that I really liked this index variable, and I want to use it inside my for loop. Actually, I really like this index2 variable because line 11 already stole my index. And I want to use it inside my for loop. Well, by simply specifying a semicolon, we've effectively skipped a component of the for loop, in this case the initializer. And we can jump right down on to the condition and the action. Let's say we wanted to perform our own action. We could do that as well. For blank, index 3 smaller than 10, and then nothing. This is also valid, but provides no benefit over using a while loop. What if you wanted to not specify a condition, action, or a initializer? You can do that too. 2 semicolons. This will result into a infinite loop. It has the same behavior as if we were to write while true. I want to point out, though, I want to point this out because you do see this used a lot, and it is a lot more common to see in C and C++ for some reason. But if you see that, just remember that that's an infinite loop. However, I would still always recommend using a while true loop, simply because this is much more straightforward, at least as far as speed reading through code. Can you use return to get out of a for loop? There's another construct that we can use to do that, but I think we're going to be covering that after we talk about switches. Okay, so here are some interesting things we can do with for loops, kind of non-standard edge cases, but something that might be a little bit more standard is if we were to go from 1 to 20 by twos. So we'd simply initialize the loop with I equals 1. The condition would be I is smaller or equal to 20, because we want to include 20. And I meant to start off with 0, by the way. And then in our action, we would say I plus equals 2. And then we would just write that out to the console. So now if we copy and paste my doohickey down here, we'll be able to see that this loop has effectively looped from 0 to 20 by twos. And we've accomplished this by simply providing a different action in the place of an incrementer. There are a lot fewer questions in this class than there are in the Monday class. I wonder if everybody's just asleep.
Possible.
Because unless you can think of another good example or an exercise.
No, I mean, if there's no questions, then we can assume we're good. We might actually end relatively on time tonight.
Yeah, but that's blasphemous.
That's funny. Oh, come on. You're really good at throwing out assignments. Come on. Come up with something real quick.
All right. Well, everybody, count from 20 to 0 backwards by twos.
There you go.
Well,
the answer's there. But anyways.
What about count from 100 to 50 by threes?
Ooh.
Yeah. So I'm going to go ahead and write the little exercise up here. Count from 100 to 50 by threes. And I'm going to reset everybody's ready button.
I mean, we could be really harsh. Since nobody has any questions, we could just pick somebody and switch to their screen and their mic and let them write it out and explain it.
Alrighty. Well, I'm not opposed to that.
Shouldn't it be 100 to 49, really?
149. Well, that is divisible by 3. Or 149.
Yes.
Okay.
So all right. Let's do this, Nelson. We won't pick on anybody yet, but we're going to hold that in reserves. So if questions don't start coming in, then we have to assume that everybody gets it, which means we have to assume that everybody's willing to demonstrate how to, do it. Should you have made your statement a question? You mean the one earlier when you said Nelson was sexy? Elevating, are you saying that you should have said, is Nelson sexy?
Actually, I did catch that elevating. I was going to bring that up right after people were after this. I was going to bring that up, but that was a good thing to bring up. I just wanted to do at least one more for loop thing.
Are you talking about scope?
Yeah. The mouthwash.
All right. Matt, good job. So Matt's A, Enrico, good. Tim, very good. Jen, look at you. Awesome. Tom, nice.
Elevated, we can still see you.
You're still typing in there, too. Unless he's not getting any... That's a nice way to test, Thomas. All right, so for those of you that got it, remember to click green. You got it. Ready.
I like my color scheme.
Yeah, actually there were several nice comments about it over here at this place, at this house. Meta, you got it?
Relaxing.
I didn't catch that. Hello?
Hello? What? Who?
Am I still here?
I'm here.
Mm-hmm.
Are you here?
Okay.
We're all here.
Okay. Well, if we're all here, I think everybody is close.
Yeah, let's go ahead at this point, just so we move forward. For anyone who's having trouble, just go ahead and demonstrate, Nelson.
Alrighty, so to do something like this, we would bring up our divider and then start with int I equals 100. I is larger or equal to 50. I is minus equals 3. So we're counting down by 3. If we were to run this, we will get 197, blah, 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 all the way to 52. Because, yeah, of the ways numbers work. But that's the output that I was looking for.
So remember, for those of you that were a bit confused when starting this out, the very first thing in your initializer is make sure that you start your value where you want it to begin at. And as Nelson had said, count from 100. So that's our starting point. So we want to set our initializer to a value of 100. And then the next thing is what's going to control if we're going to do what's in the loop. So as long as this expression, go ahead and highlight the next part, Nelson. So as long as the expression is true, we're going to continue doing what's in the loop. So you need to ask yourself, well, he wants me to count from 100 down to 50. So that means as long as I, which is going to start at 100, as long as it's greater than or equal to 50, we're going to keep doing what's in the loop. And then the final part, so our action at the end, is he wanted us to count down by threes. So we'll just take I and subtract 3 from it each time after we pass through an iteration of the loop. So if you try to break it down into 3 steps like that, you'll find writing code for for loops, to be a lot easier. Start looking at how you want to initialize it. Where do we begin? Are we counting from 0 up? Well, then we would start like down on line 32 with I equals 0. And on line 13, we want it to start at 100, and we're counting down. So we start at 100. Then the next thing to remember is when dealing with the expression, our test condition. It has to be true to run what's in the code. So just look at the specification that you're trying to write the loop for, or think about the specification, and what condition does the loop need to run. In this case, it needs to keep running as long as I is between 50 and 100. And then finally, we subtract 3 each time we pass an iteration to the loop.
Yep.
And Jen, I think you'll have got the same result with that as it happens, because 15 is not divisible by 3. The next one would be 49. So no,
Jen, very good. Awesome job.
You fluked it.
You did what, Nelson, or Gavin?
Fluked. Fluked.
I have not heard that.
It was a fluke.
Well, good job.
It was lucky.
Look, she knew what she was doing. What are you talking about?
It was luckier than unlucky.
Gotcha.
Alrighty, so the last thing that we're going to be talking about for loops, actually the second to last thing we're going to be talking about for loops, is scoping. So everybody we haven't really explicitly talked about it in class yet, but I'm sure many of you have tried to do stuff like this, and tried to immediately output that variable outside of the scope. This variable is declared inside of this scope. Once the scope ends, this variable does no longer exist. And so therefore we cannot access it from outside of the scope that's defined in, or more specifically from outside of the outermost scope that is defined in. If we were to define another scope within this scope, we could reference it. So this is everybody good as to why this is an error and this is not an error. Everybody good, everybody good. Okay, so I just want to point out really quickly that for loops are the first construct that we've been going over that actually allow you to declare a variable within the parentheses after the keyword. Now what's interesting about this is this variable is actually declared within the scope of the for loop. So you can think about this variable as being declared inside of these curly braces. So if we were to try to write out console write line I right here, you would get an error. So I just want to make that very clear that the variables we declare within our for loop are constrained to that for loop scope. If we were to instead declare the variable outside of the for loop scope, such as this, the code would become valid. I also want to point out one more weird thing about C#. This code is not valid. It says a local variable named I cannot be declared in this scope because it would give a different meaning to I, which already exists or is already used in a child scope to denote something else. There's really no technical reason why the C# compiler needs to behave like this, but it does.
Could you do I equals 10 then in that case?
Funny thing, no, you can't.
Don't.
You can't do either.
Well, that's just rude.
Yeah, I don't know what you would have to ask somebody on the C# team to actually, explain why the code behaves or the compiler behaves the way it does in this case. But that's just how it works. And if you run into this error, if you see this error, just remember that means that in a child scope, somewhere above this line, such as in a for loop, you're already declaring that variable, and you're just going to have to use a different name, and there's not any way around it. It's not a bug. It is, I hope it's, because there's this huge error message, unless the C# compiler is capable of writing its own error messages when there's a bug in itself to make it look like it's not a bug. But I doubt that. This looks very intentional. But we can reuse the variable within multiple loops. Yes, you can reuse I as many times as you want, as long as it's defined within the initializer of the for loop. Oh man, whoop.
Whopper?
Wappa?
Wappa, keep asking him questions because it's pretty funny listening to him just sit there going, whoop, whoop.
Whopa. Okay, Whopa.
Whopa.
Yes. Now I forgot your question. Is it because C# thinks it's still in memory? No. All local variables that you declare inside of a method are allocated when the method begins. There's no concept of dereferencing a value type inside of C#, and this memory will remain allocated regardless of its scope until the completion of the method. Alrighty.
Sweet.
So I think we are good. I want to point out one more thing about for loops, and that is, I guess if I wanted to be mean, I could have everybody do it themselves.
Do it, Nelson, do it!
Bring the pain.
Alrighty, well. Just so you don't use an increment variable instead of actually printing it out. Alrighty, print out all of these prices using a for loop. Your ready has been reset.
Pick somebody's screen to just randomly watch.
I can't do that. You can.
You can't do that?
No, I don't want to be mean to anyone.
Oh, I see. Well, pick on Gavin.
That won't be very interesting, I'm afraid.
I think he could do it.
Click on Phantom Walker. We all love Chris.
At least I hope Gavin could do it.
I would hope so too.
Aside from anything else, I've just finished and got up my web player tech demo of my thing with everything working again now.
Nice.
So I'm not doing any more coding tonight.
So I quit for tonight.
Who's forfeit again?
Who's forfeit?
Do you say bring up forfeit or bring up Phantom Walker?
I was saying Phantom Walker, but he just said he went to sleep. I say,
we'll see.
Yeah, try Phantom Walker. Good old Chris.
What's his name? Chris. We have 3
It's
Chris's.
Webster.
Okay.
No. Dun, dun, dun,
Get Jen to come back on.
Dun, 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 dun. Oh, if you can't do it, don't be shy. Hey, Chris.
How's it going?
Going pretty good, sir.
Yeah, I lack confidence.
Oh, come on.
I don't work well under pressure.
I have faith. Share the screen, man. Share the screen.
Never! Close all illegal stuff first.
Or just tell it to open up in just Visual Studio. Or that.
So were you making fun of my awesome, totally cool thing here before?
Yeah, how do you get it to say that?
That's just Notepad++. Oh, that's actually not that, but... Ta-da! You can add anything to it.
Cool.
And I'm totally lost now.
All right. Well, Echo? There is an
Let's
echo.
try this. Just, Chris, I'm going to mute you so we don't get the feedback
Sounds good.
from us. But Nelson can talk then. So let me switch over. Okay, Nelson. So go ahead and give him a hand.
All right, so that's as many prices as you really need for this example. So the goal is to go ahead and write a for loop that'll print them all out. So if you want to think about the problem in 3 distinct steps, you could encode that directly into the 3 different aspects of a for loop. So if you think about how you would approach this with a while loop, you would generally start off with an int index, for example. And if you were to start a for loop right now, if you just typed in the words for open paren, a lowercase 4. And then open paren, and the first step is you are going to place a variable declaration in there that's going to represent your counter. So you could simply write what you would at the top of a while loop right now, where you can actually declare a variable, name it anything, and assign it to anything. And so if you think about what the variable you need in order to produce the output you're looking for is, it's going to be something that you can increment from 0 to however many items are in the list continuously. A common word for, or common name for this variable is I. Short for index. So how would you declare a variable just normally? Just an integer variable, I mean, sorry. All right. And then if you added an initializer to it, because you're going to have to initialize it to a value first. And in this case, because it's going to be used as an index variable, you're going to want to initialize it to, well, the first index. Yep. Okay, so that's the first component of a for loop. The second component of a for loop is going to be the condition. This is what would traditionally go inside of the parentheses of a while loop. So if you think about the condition that you would want to have be true to make your loop go forward, what would you put in there if you wanted to list all of the items inside of prices? Should we unmute him?
Sure. I'll do it.
Yeah, I don't know how. Whack with poo brain. So, all right. So I'm not really sure what we would add to multiple values, if you know what I mean. Like, unless are we counting everything between those?
Well, think about what the variable that you have there is going to contain. It's what it's going to represent. You remember how you used while loops originally to loop through everything in an array? What was the variable that you used in that case?
Yes. I would have to look, actually.
Well, remember how you can access every item out of a list or an array with an index. And then the index represents, like, for example, the first item of the array is going to be 0, second item is going to be 1, and so on and so on. So you want to write code that generates a sequence from 0 to however many items are inside of your prices list. So the condition, okay, so remember that the second part of a for loop is going to be the condition. It's the same thing that goes inside of a while loop's parentheses. So in this case, it would be some sort of comparison to check whether or not your myName variable has reached the end of the list. Because the goal of myName is to be incremented from 0 to however many items are in the list, -1. So using a wait a second, are you muting him, Jason?
Yes, because otherwise it's really bad double feedback. So I've been trying to bounce back and forth. So here, I'll let him talk, but then try to do it slowly back and forth, and I can do the muting.
Okay.
Yeah, sorry. Every time he mutes it, it says muted, unmuted, muted, unmuted. So I can't hear anything you're saying.
Are we playing back through speakers right now, Chris?
That's fantastic.
You are. Unfortunately, I don't have any headphones with me.
Okay, that's what it is then.
You're on a webcam microphone, so I don't know how well that thing works.
I can actually hear you really well, but we're just picking ourselves up too. But go ahead and I'll leave it unmuted. Nelson?
Okay, so that's part of it. That's going to be the condition or the final state of myName when it's done looping. But you still need to compare Prices.count to something. Just like how you did with the array, you had that index variable and you compared it to the length of the array.
Okay.
So think of so the count is going to have how many in there right now?
2.
That's right, because there's 2 things that you added. So we're
0 and 1.
So we're going to want to loop until myName, which go ahead and change the name of that variable because that's driving me crazy. Change it to something like I. Just because that makes more sense for being just a counter variable. Okay, so we're going to start out with I being 0. This is what you're coding right now is the condition in which we're going to do the loop. So you can take that out.
Okay.
Because we just want Prices.count.
Oh, okay.
Yeah.
I got you.
So put this in for me. Right before prices, put I is less than.
Less brain.
Okay, so when we start out, the very first time through, I gets initialized to 0. So now if we look at the condition, 0 is going to be less than 2, right?
Yeah.
So that means, yes, do the loop. So let's go ahead and go ahead and put a semicolon there. And we need to increment I. Okay, good. Excellent. And then go ahead and open and close our braces. All right, so now all you need to do is print out what's in prices at each of those indices.
Yeah, it'd be I, right? Yeah. And
now in this case, well, run it.
oh, so that does print them both.
Mm-hmm. Now I'm going to mute you real quick and then just explain this.
Okay.
Okay. So if you can you give me control over on the webinar? There's should be a place over there where you can say give keyboard and mouse. And okay, good. So as we were talking about a second ago, and I think this is, I know for those of you guys that have been programming for a while, and you're in this class, you know that there's going to be times you're just going to have to hang tight because we really do want the beginners to understand this stuff as best we can. And I know for a fact there's going to be other people in this class right now that will find this helpful. So right now, when we come into this for loop for the first time, we set this, what will end up just being local to the for loop, this variable I, we initialize it to 0, so it's all set up for us to use. The very next thing we do is we check to make sure I is less than however many elements are currently being stored in prices. And prices.count, that will get us the number of elements that are currently being occupied. And we have 2 because we added something there and we added something there. So Chris was right when he said 2. Now remember, at this point, I is 0. So if I is less than prices.count, if this evaluates, this expression evaluates to true, that means we're going to do what's in the loop. So far we've just come into the for, we set up I, we set it to 0, then we came over and we said, hey, is 0 less than, whoops, hang on, I accidentally minimized my own screen, that was pretty funny. If 0 is less than 2, the answer is yes, so now we're going to come down and we're going to do everything that is inside of our braces here, so everything for the loop. So we're going to print out to the console whatever is currently in prices in the element I. Well, I has a 0 in it. So we're looking at prices sub 0, which is the very first one. So we're going to print out what's in the first one. Now where are we at after we do that console.writeLine? We're at the end of the loop. So with a for statement, when we hit the end of the loop, it always does this. It jumps back. Whoops, my bad. Let me skip over a little. It jumps back up to the action that we're going to perform, incrementing, decrementing, etc. So in this case here, I++ is just going to take I and add 1 to it. So I is a 0, adding 1 to it makes it a 1. After we increment, we come back over here, we look at the expression again. So is I less than prices.count 2? Yes, it is. So yes, we're going to do the loop. So we come back down, we write line out again, prices, and whatever is in element, what does I contain? It contains a 1. And so what's in element 1? Well, if you remember, that's in element 0. This has been stored in element 1. So it's going to print out 9042. We're now at the end of the loop. We come back up to our incrementer. We take I, we increment it from 1 to a 2. Is 2 less than 2? No, 2 is not less than 2. No, we're not going to do the loop. So we skip out and we sit here waiting for the user to hit a key because we're at the end of the line. So Chris, I'm going to unmute you and see if you have any questions.
No, I think I like to choke under pressure.
Okay, before saying anything, I was going to go ahead and mute myself again. All right, well, very good. I appreciate you bearing with us and allowing us to put the pressure on you. You'll probably never forget this again. So, Nelson, I'm going to jump back over to you now. And hopefully that helped make things a little bit clearer for some of you that are still having trouble with for loops. I completely understand, and I'm saying this to Meta, who's sitting behind me right now. She's never done any form of coding before. I completely understand how this stuff can look very foreign, very scary. I mean, are you going to hit run and the entire, power grid in the local city? Is it going to kill out? I mean, who knows? Is the computer going to catch fire? But, it's not that bad. We're not going to bring the world to an end. Just experiment, try. Worst case is you're going to end up creating an infinite loop, and then you can just close the window. Okay, so Nelson, back to you, my friend. Go ahead and code it out. Take you 3 seconds to do. just wondering what you were doing.
Yes, that was very funny.
I thought it was hilarious.
What, no link?
Yeah. So yeah.
So same exact thing that we had going on over on Chris's screen. The big thing is, again, just remember for those of you guys that are new to this, when you're setting up your variables, always try to give them a meaningful name. Where Chris had decided to go with the variable name my name as his identifier, my name is a kind of a wonky name for describing a variable that's going to act as a sort of a counter. So Nelson, in this case, could have I is typical. I and J, very common.
Yeah.
He could have also used index. He could have also used counter. Nelson, you want to add anything in on that?
Yeah, I just wanted to point out, because somebody did ask about the variable I. Under normal circumstances, single-letter variable names are completely awful and should be avoided. But I and J and K are all very well accepted in the programming community as index values or index variable names for looping. And as a result, they have as much semantic value as if you had typed the word index.
Well, really, any of the groups that you'd commonly come across in mathematics as well, A, B, C, I, J, K, M, N, O, or X, Y, Z.
Right.
That's. I always think that's kind of why you don't want to use them for things like your list name, because if you're looking quickly through it, you see a single letter and it looks like it should be an indexer, really.
Yep.
Okay, so let's go ahead and move on from here now.
So switches.
Actually, you know what? No, it's for eaches. But this is a really good time. Yeah, Jen just nailed it. This is a really good time for a break because it's been an hour since when we started the last break. So let's go ahead and take a quick break and 10 minutes, and then we'll come back and we'll take a look at for each, and then we'll look at the switches, and that will wrap up the night after taking a look at break and continue as some bonus content. So we're pausing now. All right, so we're coming back off of break. I did see a question that came in on the questions panel during break. And what about last homework results? So Gavin is joining us. I can ask Gavin real quick if he's got something quick to say on that. Gavin, I think you may have just toggled your...
Oh, yeah.
There you go.
Well, is that the one that the deadline was about 28 hours ago? Or similar?
Yeah, something like that.
No, I haven't got to those yet at all.
Okay, that's good enough.
I was marking Blender yesterday.
Okay. Nope, that's good. Thank you very much, sir. And for those that want to see how we went about doing the bubble sort, if you are having trouble with it, you can always watch the open office hours that we held yesterday. That was covered. So, all right, with that, Nelson, let's go ahead and hand it back over to you, sir.
Okay, so I'm going to write some code and then explain it, and then hopefully people are going to learn.
It's just that simple.
Next thing we're going to go over are for each loops. So we talked about while loops, we talked about for loops, and now we're going to talk about for each loops. And if you think about loops in terms of abstraction, we have the simplest loop, which just accepts a single condition. We have a slightly more complicated loop that allows you to provide three things: a variable declaration, an index, or a variable declaration, one-to-many variable declarations, a condition, and one-to-many actions. But there's an even higher level loop that we can use to make code very straightforward. So you'll see that if we have a list of integers, and we fill it with stuff, and we wanted to use a for loop, or let's just back up a second. I'm going to do a while loop first. Sorry, I've been typing code all day, so I'm making a lot of typos right now. Sorry about that.
Good night, James.
Okay. Given two of the ways that we've been looping previously, while loops, very simple. For loops, a little bit more complicated, but allows us to write a little bit terser code. We can use something called the for each loop to write even terser code. The for each loop starts with, well, the for each keyword, followed by parentheses, followed by a block. So again, very similar to what we've seen before. But what goes in the parentheses is going to be different than either the while or the for loop. We are going to start off always with a type, followed by identifier, followed by in, the keyword in, followed by a collection. And we get an error because, yeah. See, I told you, I was typing code all day, so, basic type systems just...
escape you.
Yes. Okay, so we have a type followed by identifier, followed by the keyword in, followed by the collection. Now, what this does... Yes, I do want to define the word collection real quickly here. So we have this collection right here. A list is a collection. There's a bunch of different other types of collections. You have dictionaries, linked lists, stacks, stuff like that, which we're not going to be talking about just yet. And then you also have arrays, which wouldn't necessarily be called a collection. Depends on who you talk to, really. But arrays are also capable of being used inside of a for each loop. But pretty much anything that contains a multitude of items in the .NET framework will support being able to be incremented over with the for each loop or iterated over with the for each loop. So what happens here? Well, you don't see any indexes. You don't see any increments. All you see is int price in product prices. What this will do is every iteration of this loop, it will fill the price variable that we declared right here with an item in the product prices collection, starting from the first item and ending at the last item. So now we can simply do console.writeLine price. No indexes or indices or whatever, no incrementing, nothing, just really straightforward. We want every item out of this collection and we want it in this block, and we are going to loop over and over and over again in this block until we've collected every single item in the collection. So we'll start on the first iteration. The first iteration will fill the price variable with the value of the first item in our product prices collection. Then we'll enter this block. This block has access to the price variable because it's in scope. When the block ends, we loop all the way back into the for each loop, which will select the next item out of our collection, enter the block, end the block, go back up, select the next item, and so on and so on and so on until there aren't any more items left. When there are no more items left, the for each loop will terminate and execution will resume on line 39. So we get the same results on every single type of loop. Mm-hmm. So you can see right here the complexity of the while loop. Well, it's funny, again, while loop very simple. While loop very simple. While loop is very simple.
Caveman talk? While loop very simple.
Me code. The while loop is very simple, but it requires us to write a lot of code because it's a very low-level abstraction if you want to think about it like that. It doesn't do a whole lot for you, so you have to do a lot of stuff yourself. For loop is a step up. It does a little bit more stuff for you, but it doesn't do everything for you when you're looping over collections. A for each loop is the simplest way to iterate over a bunch of items in a collection in .NET. And I'm not talking about Link right now. I'm just talking about in straight-up code. Well, Link is code. I'm talking about in straight-up language constructs. The for each loop is the built-in mechanism in C# to loop over multiple items in a collection repeatedly until we're done. So I don't know what much else there is to say about the for each loop. I mean, I can iterate some of the points about them. First of all, the for each loop is typed, meaning the type of variable, and you have to place a variable here. The variable has to have a type and a name. And the type of that variable must match the type of the collection. Meaning, as you saw before, when I was just typing out code without thinking, I had the string type. I can't even type it now. String type, which is going to be invalid because string is, you can't convert a string or an integer into a string. So we must use the integer type here just because product prices is a list of int. So there's, I mean, I don't know much.
I mean, it's really that simple.
I mean, I could expand the code for them.
Sure, if you want to. I mean, or you could just have them write something using it.
Well, any ideas?
Nah, if there's no questions on it, let's go ahead and jump over to switches.
All right. I wonder if I should just expand it, though, to freak people out. Because that's always fun.
Then do it.
All right. Well, I will.
Okay. It's about time. Now that's just pure evil. I did not realize that's what you meant by expand, but okay.
That's what I was talking about.
Okay.
And if you run this code, we'll get the same result. This is actually what the for each loop expands into. But some of this stuff we haven't really talked about quite yet. But I just wanted to point it out that the for each loop isn't magic. It's just expecting that the collection it has this magical method. I just contradicted myself. Has this particular method called getEnumerator, which lets it does its own thing over and over and over again. So again, for each loop isn't magic, but it writes a whole lot of code for us.
And yes, Ken, just to let you know, the price identifier was only scoped within the for each loop.
Yep. Just like for loops, this variable declaration is only valid within this block. Alrighty.
Okay, so switches.
So, yeah, switches. So, switches are there, I guess. I mean, they're all right. If we wanted to write code that said something like, we wanted to get a selection from the user, something like a console write line, enter 1, 2, 3, or 4. And then we wanted to do something depending on if the user entered 1, 2, 3, or 4. So we would do something like if selection equals 1, then console.writeLine moo. Else, if selection is 2, console writeLine quack. Else, if selection is 3, console writeLine bark. And if selection is 4, console writeLine meow. I don't know how I spell meow. And finally, console writeLine you entered an invalid selection.
No, Brandon, your question is there. Nelson, we need to make sure before going too far. There was a question from Brandon and Jen.
Does for each exist solely for arrays and lists, or does it have other uses? It does. Well, you can do some fun stuff with for each loops. But generally speaking, you'll be using them with arrays and collections. Yes, that's what the construct exists for. Can you read the for each syntax? Well, I can bring it back up again in a second. I'll copy that. Do. So this reads for each integer price in product prices. So it actually reads very, 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 very similarly to how it's written now. It's a very nice, clean construct. Is for each good for modifying collections? You had to say that, didn't you, Thomas? But that is a good point. Okay, so what would happen here if we said product prices dot remove at 1? What's everybody's guess as to what's going to happen here? BSOD. I hope not. Ponies. Of course, the answer is ponies, actually.
They just burst out of the screen.
We'll remove all but one. Good answer, but not correct. Keeps looping and keeps leaving one. Good answer, but not correct. Yeah, actually, those were a lot of good guesses. But the actual result is an exception. No, it does not make babies. You get an invalid operation exception. You get it immediately after. Immediately after the next iteration of the for each loop, after the product price was successfully removed. But what's going to happen is the next time you hit the for each loop, you're going to get an error saying collection was modified, enumeration operation may not execute. So if you ever run into a situation where you need to modify the collection you're enumerating over, you need to rethink what you're doing. The price identifier only scoped for each loop, and it wouldn't be usable if declared again, right? Just that you can't do int price because that's going to have the same issue about the local scope. But you could, for example, do multiple for each loops with price. All right, is that good on questions? Yeah, TF, you did bring up a good point because that is something that people will get confused on. Okay, so bringing back this code, best program ever. Very simple logic. But what we have here is kind of messy. It's kind of long. Now, we could use if-elses, and I generally would use if-elses myself, but we haven't talked about how that syntax works or anything, and it could be confusing to people who are new to if statements. But there is a construct within the C# language that actually okay, Dave actually asked a good question. Even if you're, sorry for getting sidetracked again, but this is a good question. Even if you're modifying the values in the list, add 10 to every price, no, you can do that. You can modify the items all you want, but you cannot modify the actual collection itself. Okay, but C# provides a language feature for these sort of scenarios that we're going to be talking about, and that's the switch. So this particular scenario is when we have a variable and we want to compare it to a list of constants, and only one constant per variable, or only one constant, and we want to perform different logic depending on which constant that we hit, and we optionally want to provide a default behavior if none of the options are hit. So we start off with the switch keyword, followed by parentheses, followed by a block. So Again, very common pattern in C-style languages. Inside the parentheses, however, goes a variable, just a variable of any type. So now we're switching on selection. Now what goes inside the block? What goes inside the block is actually a little bit different than anything people have seen thus far. What goes inside the block are case statements. And what we do is we say keyword case, followed by space, followed by a constant, followed by a colon, followed by, well, a new line in this case. Then we type in code. And then when we're done typing in code that's going to be executed for this particular case, we break. So we can follow this pattern as many times as we want. We can say to console write line quack break, case 3 console write line bark break, case 4 console write line
Meow.
Who was that?
Not me.
Wrong input.
Okay, so this code right here is perfectly equivalent to this code right here. The switch statement is basically just going to switch on a variable to constants. And those constants must be assignable to that variable or comparable to that variable. We could not, for example, say 2 right here, because this switch statement is switching on the int type. The reason it's switching on the int type is we have an integer expression in here. This expression evaluates to int because it is a variable reference that is of type int. Therefore, we cannot switch on any constants that can't be convertible to int. So we must provide a constant that's convertible to the expression that we're switching on. And then again, just to reiterate, we start with the case, we follow with a constant, then a colon, and then code. And we can enter as many lines as we want inside here. And then when we're done, we hit break. What break's going to do is it's going to resume execution all the way down here. It's going to skip everything else in the switch statement. Finally, at the end, we have this default. So default followed by colon is going to have a similar syntax to the case statements in that it also requires a break, but it's going to execute if none of the previous cases were matched. Can you reference the case to an index without knowing the value contained in that index? Can you reference the case to I'm not sure I understand. So a list index or array index 3. Reference the case to an index without knowing the value contained.
I think she's saying so it would be like case index 3.
Oh, so you mean something? If I had a collection up here. Are you asking if I can do something like this? Because in that case, that's a no. Then the reason is that is an expression, not a constant. Remember the difference between an expression and a constant. Well, a constant is an expression, but it's a constant expression. In this case, this expression requires evaluation, which isn't possible to do inside of cases.
If you wanted to do that, you could make a variable just before the switch statement.
No, even that would fail too. If I did,
would it?
Yeah, because it's not a constant.
Huh.
You know what's funny is I thought you could do that too in Monday's class, and I tried doing it. I was like, oh, wait a sec, you can't do that. Because I don't use switch statements very often either.
Well, that makes me feel better, but also I was there and I didn't notice, obviously.
How would you be able to make the case more dynamic? Well, you really wouldn't. Cases need to be used with constant values, and there's no way around that.
The thing they're most handy with is probably beyond this point, but I would say is enums.
Yeah, I will use cases with enums just because ReSharper generates all the statements for me. Can you not use a variable? Okay. Can you give a quick refresh on break? Break is simply what's going to mean. Think about break just like this end curly. It just signifies that the expressions you were typing into this block are done.
Falling through?
Yeah, there's that. You could do like 4 and then 5 and then 5 and then 6. So you could omit all the expressions inside of them and they'll fall through to where this will match 4, 5, and 6 and then break. But you cannot actually put logic in here if you fall through. As you see, control cannot fall through from one case label to another. So you cannot use a variable to identify a case. No, cases, they must be constant. And I did get a question about strings, and the answer is yes. If this was a string variable, so if I said string meister equals hey, and I did meister, I could k match based off of strings, because strings in C# have a literal syntax that get evaluated into constants. So that would work just as well. Except for that.
What are the chances?
Oh, wow. There we go. Well, I did, this is how you would do it off of a parse. As you can see, on line 12, I do an int.parse, so I get an integer back, and then I switch based off the integer instead of a literal string. I don't get it. Yeah, what forfeit posted you can do, just like what I showed just a minute ago. But you don't declare that it's an int in the case. How do you know it's evaluating as an int, not a string? Good question. The switch statement at compile time knows that the selection variable is an integer, and you can see that right there. If you hover over the variable, Visual Studio will give you the type, and you can see that the compiler already knows that selection is an integer. Therefore, it can type the switch case to an integer. Oh, no, you can't do that. You cannot use variables inside of the cases, inside of this part. These must be literals. They cannot be. Well, I already said I don't use them very often. Jen, did I answer your question about how it knows that we're working on an integer type switch? All right, sweet. I don't know if there are any more questions about switches, now is a good time. We haven't talked about const yet. Change switch information to interpret command line args. I mean, they're very boring language construct. It's just a bunch of if statements with limitations and greater amounts of indentation and words instead of curly braces. All right, so if everybody's good, I guess it's time to move on to break and continue.
Yeah, and that's really just bonus content, really.
Yeah, I have more than enough time this class, but we even got that in last class, so we might as well.
Let's do it.
Alrighty, my awesome, useful, awesome code is about to be deleted. So sorry about that. Okay, so breaks and continues. Well, actually, let's bring up this. Alrighty, does everybody remember this program? And I can even throw on an awesome for each string product in product names. Oh, this is going to be so much nicer being able to use for each loops now than forgetting my stupid index incrementing. Okay, so breaks are a really cool feature of looping. In this case, what we have here is an exit variable, and we assign the exit variable to true when we want to exit the loop. But the C# language and many other languages provide a much cleaner way to exit a loop than simply using a flag like this, and those are called breaks. So what I'm going to do is I'm going to delete line 13 because we no longer need it. And then in my while loop, I want this to be an infinite loop. I want this loop to continue forever until I explicitly tell it to stop. And instead of setting the exit to true here, I am simply going to type in the keyword break, followed by a semicolon. Now, if I were to run this, I would be able to enter product names, enter a blank line. It would break out of my loop and print out my names. So you'll also notice something interesting when you type this out. Visual Studio will highlight the loop that this break statement is associated with. So you'll easily tell which loop this is breaking out of. Because what happens is this break statement will end the looping of its parent loop, of the closest loop up in the chain. Breaks will work in for loops, while loops, and for each loops. For example, I could say, if product equals, I don't know, pony, then we could say console, ugh, I'm done with this. Break. So in this case, I simply say if the product name is pony, then we're going to write something out and we're going to break out of the for each loop. So if I run this, and I do stuff and pony and things, and hit enter, and then finally followed by an empty line, we'll get stuff and pony and ugh, I'm done with this, and we'll exit the loop. So that's how breaks work. Like I said, they work in while loops, for loops, and for each loops, and do while loops. We haven't talked about those. Is everybody good with breaks? Did you just program Gav?
What? Where? Who? Why? What? How?
Did you see my for each loop?
Go back to sleep, Gav.
Of course I did. I wasn't asleep. I was working. Oh, God.
Okay, anyway. So what if we wanted to write what if we wanted to do something where when a certain thing happened, we don't want to break out of the loop, but we want to stop the execution of the loop for this iteration and continue on later. So I can say if product is stuff, so now if I go ahead and write this, or run this, we'll get this stuff, and then this stuff, then we'll type in stuff, hey, things, and stuff, and then we'll end it, and what do we get? We get that, and then that's a terrible name instead of the word stuff, then hey and things, and then that's a terrible name instead of stuff. So what's happening with the continue keyword is it's working similarly to the break, except for it's going to continue, it's going to skip the execution of the rest of the loop and continue on the next iteration of the loop. So is everybody good with continue? Remember that continue and break will only apply to the parent-most loop. So if I had nested loops and I put a break inside of the nested loop, it would only break out of the nested loop and it would continue executing the parent loop. But it doesn't execute writing the stuff. Yes. The continue, immediately when it gets to this continue statement, it's going to jump all the way over the rest of the code in the loop and then start back again. And remember, breaks and continues work on both, or on all of the loops, whiles, fors, and for eaches. So,
okay. Well,
so everybody's.
I think the next thing is going to be talking about the homework.
Yeah. Homework. I can actually just cheat. Oh, come on. Okay, this is the homework. The goal of the homework. Ooh, we just had a question.
Okay.
What do you think?
I would rather. Hey, Enrico, let's hold off on return until next the next class for those that. Yeah, that'll work best because we're going to be getting into methods and all.
Alrighty. Okay, so the program is to build a basic game. I've learned the game's name as Hang In There, although apparently it's also called Mastermind. And the goal of the game is to guess a random 3-digit number that the computer generates. The code for generating numbers is right here. So be sure to grab that if you've never generated a random number before. So this will generate a random 3-digit number. Make sure that you have random equals new random at the top of your line or top of your method. The computer will generate a 3-digit number and then it'll allow you to guess. And after every guess, it's going to redisplay all of your previous guesses. And this is if you didn't actually correctly guess the number. But it's going to display all of your previous guesses and organize them into 3 columns. The first column is not close, the second column is close, and the third column is hang in there. The not close column, your guess will go in here if any of the numbers in your guess do not match up with any of the numbers in the goal, in the program, in the number that the program has generated. It will land in close if one or more of the numbers in your guess are in the goal number, but they're not in the correct place value. it'll go and hang in there if one or more of the numbers are correct and in the right place value. And then finally, once you finish and finally guess the number, you'll get a success. You took X amount of guesses to find the goal number.
Yeah, I've already seen a few of our students that have successfully completed the homework and posted about it and link requests on Facebook, which was pretty cool because we've had people coming back saying that they played the game and they enjoyed it, which is awesome.
Yeah, definitely. So Java, it is basically a simple guessing number game. The computer generates a random 3-digit number, and your goal is to guess it. But after every guess, it'll format this table for you so that you can it's just basically a logic game.
So without giving away logic, can you come up with an example to show people how to format something that looks like that, but with something else?
Do you want me to actually have a list of integers or not?
Or a list of strings, or
how about, I was thinking more like a big arrow pointing downwards in ASCII Art. So start off with it 10 spaces apart and work your way down.
Well, the only reason I was suggesting the other is just to pull something from a loop.
Okay, so do you want me to tell me if I'm giving too much away? So keep an eye out.
I don't think just like with the bubble sort stuff.
This is hard given the stuff that we've shown. I wonder what the best way. Let's just go ahead and do it the easiest way, just most straightforward way. If 2.count is greater than and remember, just tell me to stop if I'm going too far. Jason, or do you think this is good so far?
That's fine.
Oh, you mean keep on going?
I was just talking about, because Meta was asking some interesting questions earlier about how would you even get the formatting, to show the table, basically the table style printout that you had. So I wasn't really suggesting getting into all of this. I was just suggesting taking some simple things and demonstrating how you could print from one, some spaces, a pipe symbol, print from another.
Oh. Well, hold on. Let's see. 2, 3, 4, 5, 6, 7, 8, 9 equals 9 minus I dot toString dot length.
You could have just kept it super simple for a beginner and just put spaces in there, you know.
Huh? I'm putting spaces in there. Because there's going to be instances where the numbers are a little bit longer. So there's a padded table.
So if anybody wants to copy that, hit reset on everybody. Nelson?
Yes.
Okay, so if you don't need to copy it, just go ahead and immediately click on ready. And for those of you that, just so that we know the difference between those that are AFK and all, for those of you that want to copy it, go ahead and click on 1 minute. Okay, sweet. And then, Ken, we'll come back to you in just a second in regards to how the results, well, we'll talk about how the results are obtained. I mean, we know how to ask the user for a number. And since it's got to be a 3-digit number, we know how to check to verify, one, it's a number with try-parse. And then if it's a number, we can then turn around and check to see if it was less than 100 or greater than 999. If it is, then the number's too small or too big. Okay, so for those of you that are copying, remember to go ahead and switch over. Yes, the numbers that, I see what you're asking, Ken. The numbers that were in the example given by Nelson over on 3D Buzz were numbers that were entered by the user.
Right, that was just an example
of the game being played out.
So did I hear rumors there might be an end-of-term exam?
Yes, you did.
Cool.
That way, and here's why, Gavin, because I don't want people that are taking this course that truly are beginners to be stressed out that if they fail one homework assignment, I still want them to try resubmitting and trying to get it right, but I'd rather see a student trying and then at the end of the course have an understanding of the basic concepts. That doesn't necessarily mean that they're all going to have perfect logic solving skills. And so I would very much rather them just get the concepts down and be able to pass the 101 class. Because for some people, logic just simply develops over time.
Yeah.
So, because we had a lot of people that were really stressed about the bubble sort. And Gavin, Jen's asked a question. If you want to address it, just saying, what are the resubmission guidelines and the time frame?
resubmission.
Yeah, if somebody fails a homework and you...
I think could be up to 7 days. It may be less.
I don't think we ever said there were no resubmissions.
Yeah, I didn't say no resubmissions.
I keep hinting at it. No, I've with the first weeks I gave them.
Oh, that's for Blender.
Until no, with for the first weeks of the C sharps, I seem to have a lot of S's. I gave them until the deadline of the second week to resubmit the few who had to. But then I had marked it the next day. So, but I think 7 days seems fair enough to, if there is a resubmission.
Yeah, however you want to do it, Gavin.
For the most part, I think people should be okay with it. I think one thing that has come to notice with a couple of people I've spoken to is that they've both had the experience of banging their heads against the problem and into the small hours, and then waking up the next morning and just sitting down and coding it out in about 20 minutes. This is this is how it works.
Yes, with all of
your
us.
Brain, your subconscious processes it while you sleep and perchance dream. So yeah, if you're getting frustrated and steadily drunker in your eagerness to emulate Nelson entirely, then go to sleep, do something else.
Well, I'll
shoot some things on the game.
I'll make sure to let Zach know that in the C# class, just so there's no confusion, that there are resubmissions. Because resubmissions are allowed. I am more interested in students simply. I really want them. I want you guys trying.
I read that article the other day. That's a really good article. I totally agree with it.
Which one?
Jeff Atwood. He posted. He's one of the co-creators of Stack Overflow. He posted an article about rubber duck problem solving or something like that, where he's noticed that people, they'll have a problem and then they'll go to type it out, and as long as they're typing it out in like a really clear language, they'll end up solving their problem as they're writing it. So a common thing, it recommends, the anecdote was this guy, the lead developer, had a rubber duck next to his desk, and if anybody wanted to ask a question to him, they had to ask the rubber duck first. And then he said half the people ended up just answering their own questions and walking away.
That's brilliant. I'll have to read that.
Talk to the duck, because the hand is busy typing.
All right, so back to any questions. I think pretty much everybody's got it by now. So any questions back to the homework? Nelson, you want to go ahead and pull that back up?
Yeah. If I can find it. Because Ultramon doesn't like to show me where my windows are.
I can't help that you don't keep up with them. I've got windows all over the place.
I also have an extra monitor.
Thanks to me.
Yeah, but still.
Well, I guess I can get some more monitors if that'll make you feel better.
No, it's just harder to keep track of 4 taskbars when there's not a central location for all your...
Categorize where your windows go.
I do most of the time.
Then you should know exactly where it's at.
Yeah, but sometimes I have a Chrome window open on some place for one reason, another Chrome window open for another reason.
Not categorized. Answer questions.
Okay. Where do you check your grades at? I think Gavin will be doing that.
Well, it's really more of we're not. It's a pass-fail system we've got in place, the same as with the Blender class, and really, it's more we want the assignments to check that you are understanding what we're teaching you, and so it's like with the resubmission, the people who it's not like they've failed. It's just that they've, in fact, for the most part, for the first week, they were, quote, silly mistakes. Just a lack of practice at testing out every possible way of breaking their code, rather than any desperate failures with their logic. And it's more about getting them to pass it. So, basically speaking, unless you're doing really badly,
yeah,
you shouldn't be hearing.
Yeah,
from
the most
us.
important thing is and if you are doing really badly, we want to help you. We want to see you succeed at this.
If user input is invalid, should we be able to detect the program to accept input again without restarting the program? Yes. If the user input is invalid, the program shouldn't crash or terminate. It should just indicate to the user that they don't know how to follow simple instructions and are probably not competent enough to even play the game.
And Ryan said, so if we don't hear from you, we are okay. Well, yes. Never be sure. It rather depends when I get them all marked. And
now, I don't think. Did you put error checking as a requirement in this one?
You didn't originally.
You didn't, but it's at this point you have been taught how to go about doing that.
Well, after every guess, and the guess is defined as being a 3-digit number.
Yeah, so that's true.
Remember, in the real world, clients aren't going to tell you to make sure your programs aren't going to crash before you submit it to them.
This is very true.
And then they'll complain when they break it by putting in an input.
Hey, Nelson, you know what today is?
Today is iPad
For
day.
me.
Well, today
That's
for you.
right. Woo!
It'll be iPad day for me in about an hour and 45.
TF, it was delayed for people that did not get their order in, like in the first couple of hours. Mine's been sitting in Nashville now for, what, 5 days, 4 days now? Just 25 minutes down the road.
Mine's been in Seattle for 6 hours.
Ooh, Matt, nice. You get your iMac tomorrow. Darth, we've been talking about it, how we could break into the FedEx facility, you know. Instead of just taking one while we're there, might as well take 5 or 6.
I will. There's a question about how I'm replying. I will be using the PM system as first port of call.
Which means submissions to the PM system, those aren't being seen by Zach,
no,
are they?
We're not having submissions through the PM system. The question was, we submit homework by email. Is it safe to say Gav will respond by PM or email?
Okay, my bad.
Sorry, no, I should have read it out. It's getting late. Well, it's getting early. No, I'll be responding by PM.
Gotcha.
Jen, but still continue to give them the chance to enter correct input. Yes.
Make my life easy as a very dumb user.
You suck. Game over.
Yeah.
You win a cookie. The end.
Days.
You just start the game and it immediately says you win. Game over. No user input, so you can't do anything. It just says hit any key. There you go. So there's some user input.
I wonder if anybody's going to write a program that just console write lines this out.
I sure hope not. All right. Well, I think we can go ahead and wrap things up now. For those of you that were not here during, I guess it was open office hours, I mentioned this. While C++, the registration and all is not up, I'm hoping that that'll go in place Monday. I did want to let you guys know that it is not going to be a 6-week program. It's going to be an 8-week course. We need those extra couple of weeks to cover everything that we'd like to cover in the 101 class.
I just got a question about asking a question. The answer to that question is yes.
You're talking,
but will we
talking about the unrelated question?
About
yeah.
BuzzNet? That's
yeah.
related.
No. C# is still 6 weeks and will continue to be. The next program, or the next 102, the 102 class, the next C# class, will be another 6-week class. It's a little bit easier with C#. C++, not quite as easy.
Yeah.
Are you planning on having a final roundup of because obviously the last homework, the week 6, will be handed in a week after the last?
Yeah, we'll end up talking about that.
Might be something to think about.
Yeah, exactly.
It just occurred to me earlier.
The question was, does BuzzNet authenticate based off the vBulletins user database? Yes. So you'll be able to use your forum username and password. Probably not anytime soon. As far as teaching assembly, it'd be fun, but
teach binary.
Was that a pretty complicated thing to set up? I'm just asking because I have vBullets I like. No, it's actually you just hit the table, and you have to remember to MD5 you have to MD5 the password twice. So you MD5 the password, and then you append the salt to the MD5 password, and then you MD5 that. That took me it took me about a few hours to figure out.
Talking about it took me just sitting there with you.
No, Nelson, is your floor giving way?
It's my what?
Is your floor giving way?
No, it's my stress ball that I like throwing up in the air. I have to be doing something with my hands. I don't have any bottle caps. I have ponies, but they're still in there.
Okay. You've said enough.
Dude.
That's yeah, it's time to end class. Well, guys, thank you very much for joining us tonight. It's greatly appreciated. The night class did slip this week. We diminished about almost 2/3 of the class ended up not showing up. So a bit smaller than we were hoping to see, but that's okay. We will be back here again Monday with the next iteration of the C# class. And again, you guys are welcome to attend that class. I know there's some of you guys that are here right now that are actually part of that class that are just hanging out here. So always feel free to jump into whichever class you would like. Good luck with the homework, and thank you guys for jumping in. You did not fail us, Chris. You did not fail us at all. You did great. Fun classes, though. Thank you all for participating, and it's a really good time. So we'll see you guys on Monday or around 3D Buzz before then. Good night, everyone. Bye.
Later.
Bye.